Hello friends, welcome to Live Here Do Mathematics. So for starting Riemann integration, one of the most basic and fundamental tool of Riemann integration is partition. So first we have to understand the concept of partition. So let us start. So what do we mean by a partition? So let closed interval AB be a closed and bounded interval. Okay. So a partition of closed interval AB is a finite ordered set. Look, ordered set of the type xi, where the xi's are like this, where the starting point A is denoted at x0, then x1 is strictly greater than x0 and x2 is strictly greater than x1, and so on. Xn is the endpoint B. So the points x0, x1, x2 and xn, the set of these n plus 1 points is a partition of closed interval AB. Okay, now let us understand by examples. So here two words are important. One is finite. A partition is always a finite set of points. Okay, so the set P cannot be infinite set, and it is ordered set. Okay, so the elements have a order. Generally the set has no order, but here a partition means a ordered set. So where is order? Look, the order is x0 is less than x1 and x1 is less than x2 and up to less than xn. Okay, so now let us take some examples. So suppose this is our real line and this is point 0 and this is 1. So actually this is the closed interval 0 1. Now we are taking the point 1 by 2. Okay, so this is a partition. So the partition is the set of points 0, half and 1. Okay, so this collection of these 3 points is a partition of closed interval 0 1. Now look, what do we mean by these 3 points? So if you take these 3 points out from the closed interval 0 1, that is, we cut these 3 points by a knife, then we will get 2 closed intervals. One is 0 half and the other is half 1. So a partition actually breaks the interval into sub intervals. Okay, so now let us take another example. Suppose this is our real line and this is the point 1 and this is the point 5. That is, this is our closed interval 1, 5. Okay, now let us take the partition as the set of points 1, 2, 3, 4, 5. Look, this is a finite set. 1, 2, 3, 4, 5 points are there, and the set has ordered. That is 1 is then 2, then 3, that is 1 is less than 2, less than 3, less than 4, less than 5. This is the order. Okay, so this is the ordered set and this is a finite set. So this satisfies the two conditions of finite and ordered. So okay, so two conditions of partition, and these points are like this. So 1 is the point this, then 2, then 3, then 4. Okay, now actually what does this 5 points do to the interval 1 5? It breaks the interval into 5 parts. Look, sorry, 4 parts. That is 1 2 closed interval, then 2 3, then similarly 3 4, then 4 5. Okay, so actually a partition breaks an interval into sub intervals. So for an arbitrary collection of partition, okay, so now we taken here the partition of closed interval 0 1 as 0, half, 1. We can also take the partition of closed interval 0 1 as, so we can partition also like this. We can choose these points 0, 1 over 4, 1 over 3, 1 over 2, 2 over 3, 3 over 4, 1. Okay, look, this is also their set as a order. So this is also this order maintains, and this is 1 2 3 4 5 6 7 points. So this is a finite set. So this is a partition of closed interval 0 1. Look, here we had a partition and here we have another partition. So it is not necessary that a set has only a interval has only one partition. There can be many types of partition. We can partition it as many ways we can think of. Okay, so now let us give a notation. The family, okay, of all partitions of closed interval AB is denoted by this scripted P of closed interval AB. This is scripted P. Okay, scripted P of closed interval. This is the collection of the family of all partition of closed interval AB. Okay, so now arbitrarily, if P equals to x0, x1 ... xn, if this is a partition of closed interval AB, then P divides the interval closed interval AB into non-overlapping subintervals like a comma x1, x1 comma x2 dot 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 up to xr minus 1 comma xr and up to xn minus 1 comma xn. Okay, so a partition subdivides the interval into non-overlapping sub intervals. Okay, now the rth interval is this. Okay, so the rth interval is generally denoted by delta r or del xr. This is equals to xr minus 1 comma xr. Okay, so this is the rth interval and this is denoted by del r or delta xr. Now the length of delta r is the end point minus the initial point. Okay, so the length of interval is basically the end point minus the starting point. So this is the length of delta r and the rth interval is denoted by delta r. So thank you friends, hope you have understood the idea of a partition. If you have any question, then please let me know the question in the comment section, and hope you will enjoy the video, and please subscribe the channel and don't forget to share the video with your friends. Stay tuned with us because we will come back shortly with this kind of video again. Thank you.